Hello everyone, we're continuing through mock set 5 and let's have a look at paper 1 and let's have a look at this question 8. So it says figure 4 shows the sketch of a curve with the equation y is equal to f of x. Write down the number of distinct roots of the equation f of x equals 0. Okay, that's quite nice and straightforward. That is just literally how many solutions are there to this quartic equation. And we can see we've got one there, we've got one there, we've got one there, and we've got one there. So the answer to that is that there are four distinct roots to the equation. So f of x equals 0 has four roots. The next point, let's have a look at that. It says f dashed of x is equal to 0. Okay, so f dashed of x equals 0. What that's basically saying is, where is it the case that the gradient is equal to 0? And the gradient is equal to 0, we can see there, and there, and there. So therefore, f dashed of x is equal to 0 has three distinct roots. Okay, so that's quite nice, actually. We're getting towards the beginning of the paper now, so that was part A done. Now, part B, on the diagram 1, sketch the graph of f dashed of x. Right, let's have a little think about this. This is one of those bits of the syllabus that is not very often examined. So they've basically put a little blank axes there ready for sketching it. And I'm just going to bring across from the Edexcel textbook a little table here that will assist us in terms of how we approach this. So this is sketching a gradient function. Now, this little table tells us all the sort of like criteria that we need to be aware of. Let's just have a little look at this actually and think about what's going on here. So it says you can use the features of a given function to sketch the corresponding gradient function. This table shows you the features of the graph of a function y is equal to f of x and the graph of its gradient function y equals to f dashed of x at corresponding values of x. So we can see that if we've got a maximum or a minimum in the original curve, then the gradient function's graph will cut the x-axis. And that's because f dashed of x equals 0. So you can see here in this quartic that this turning point has gone to 0. And this stationary point has gone to 0 as well. So that's the first thing to be aware of when you're sketching these graphs. On the bigger picture, I would also say as well, is notice that if we've got, in this case, a quartic, which the highest power is 4, and it's a negative coefficient in front of the highest power because it's an upside down one, then when you differentiate, it's going to go to a cubic and it will still be negative. So we're going to expect it to go into that kind of shape. So that's super useful because you're saying to yourself, okay, whatever this graph's going to look like, I know it's going to have that kind of shape. And by the way, it would be, so let's imagine we had a quartic that was like that. So with a positive coefficient in front of the highest power, then we know that it would go to a gradient function that would look like that. If conversely we had that was our original function and we differentiated, we know that what would happen is we would expect the graph of the gradient function to go to a quadratic. And by the way, if we had a quadratic and we differentiated, we'd expect the graph of the gradient function to go to a straight line. So that can be a useful rule of thumb for thinking about what the graph's going to look like. Okay, so in this example here from the textbook, we can see that we're expecting this kind of shape, so we bear that in mind. Now let's look at the other pieces of information that we're given. We're told that a point of inflection just touches the x-axis, okay? We're told that a positive gradient is that we are above the x-axis for the gradient function. And you can see here we have a positive gradient in this bit that I'm indicating with the cursor. So therefore the graph is above the x-axis in that portion. A negative gradient is below the x-axis. Here we have a negative gradient in between those two stationary points. And so we can see that we should be entirely below the x-axis for that portion. And again, because we know we're expecting the shape of a cubic, that's how we know to fill it in that way. And then finally, we've got a negative gradient also from here to here. And that means that this negative gradient from here to here is going to be below the axis. Notice that this particular turning point is a point of inflection that I'm indicating with the cursor right now. And here it says a point of inflection just touches the x-axis. So that's how come in this particular example, notice it's just touching the x-axis. Okay. It's a bit annoying. You just kind of like got to remember these different features in order to successfully be able to produce your sketch. But bringing together all those elements, bringing together that it's going to cross the x-axis there and there, that it's going to have this general shape of a cubic with a negative coefficient of x cubed, that the gradient is going to be, gradient function is going to be above the x-axis in that portion, below the x-axis in that portion, below the x-axis in that portion, and that as this is a point of inflection, it would just touch the x-axis at that point. Okay, so that's how you make use of all those information to sketch the gradient function. Two other little things to note are that a vertical asymptote just remains as a vertical asymptote. That's kind of good to know. That doesn't change. And a horizontal asymptote becomes a horizontal asymptote at the x-axis. Okay. All right, so let's apply all of that logic to our graph that we've got here. And what can we say? We can say, first of all, it's a quartic, and it's a quartic with a positive coefficient of x to the fourth. So we can say that we expect our graph is going to be looking something like that. So that's the first thing. The second thing, we can say that we know that it's going to cut the x-axis at 3 points where our turning points are. So there's one, there it is. Here's the other at the origin, and there's another there. Oh no, sorry, that's not a turning point at the origin. Let's get rid of that one. Okay, the other turning point, sorry, is just to the right of the origin here. And then we've got another turning point there. Okay, so we've dealt with that one there, this one here, and this one here. So we're cutting the x-axis at those 3 points. Now, to be honest, at this stage, we can more or less just sketch it really, because we can say it's got to have that shape. It's got to go through those 3 points. So we can just, at that point, immediately sketch it. And that's what it would look like. Just checking, sense checking that. We have a negative gradient up until this turning point, and we are below the x-axis, so that is correct. We have a positive gradient between here and here, and we are above the x-axis in that portion. We have a negative gradient from there to there, and we are below the x-axis. And then we have a positive gradient from here to here, and we are above the x-axis. And in this case, in this particular case, we don't have any points of inflection. Okay, so that's fine. That's our sketch. Now, sometimes students say to me, does it matter about the scale? And do I need to, like, for example, label where they are? That depends on the individual question. Sometimes they can expect you to like label where things cross the x-axis, but as in the original graph, it's very generic and there's no information given. So you're not going to be required to write down where they cross the axes, any coordinates, for example. And I think don't worry too much about the, gradient. I think as long as the shape is correct, you're going to be okay. Now let's have a look at the mark scheme and see where the marks are. So what have we got? We've got one mark for left of the y-axis that we have got start negative on the left-hand side, crosses the horizontal axis here, followed by a maximum to the left of. So if you've got this portion right, or by doing either that bit or that bit, you get one mark. To the right of the y-axis, they're saying starts off on the positive, to the right of the y-axis, starts positive, so we are positive here, crosses the horizontal axis, followed by a minimum. Okay, that's fine. So they're saying if you've got those, you get that mark. And then finally, there's another mark for the correct shape of the gradient function, that it's a cubic, that it has a maximum and a minimum broadly in line with the x-intercepts of C, and that there's a positive y-intercept. So basically, it's just as long as the shape is looking correct. And yeah, that's how you approach questions of that type. It's not examined very often, and people are often a little bit unsure about it, but that's how you would do it. I hope that you found that helpful, and I will see you in the next video.